This is CPM Precalculus Chapter 1, number 105. So we're asked to use the Pythagorean Theorem and the figures to the right here to answer the following questions. So remember that the Pythagorean Theorem is c squared is equal to a squared plus b squared for a right triangle where c is the hypotenuse and a and b are the other legs. Okay, so part A is asking us, look at the square to the right, what has length n for each side. What is the diagonal? So what is the length of the diagonal? So this is the square, right? We have n and n here. We also have n and n here because it's a square. And so we want to know the length of this diagonal right here going across. Well, using the Pythagorean theorem, we know that since it's a square, all these angles are 90 degrees. And we could use the Pythagorean theorem. We just look at, let's cut this square and just look at this side. So we cut it at the diagonal, and we can see here that's a right triangle. And using the Pythagorean theorem, we have d squared, which is our hypotenuse, is equal to square of n plus square of n. So combining like terms, we have 2n squared is equal to d squared. Square root both sides, we get d is equal to plus or minus square root of 2n squared. Since we're looking at actual lengths, we cannot have a negative length, so that's just equal to positive, or square root of 2n squared. And we know that the square root of n squared, right, is, so we could split this up and it's square root of 2 times square root of n squared. Square root of n squared right here is just n, right, because these cancel out. So we have square root of 2 times n. Okay, so this is the length of our diagonal here. Okay, so d is square root of 2 times n. Part B asks, what is the measure of the angle labeled x? So again, our square is like this. We have n, 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 and n, and this is our angle x right here. Well, we know this is a 90-degree angle, right? These are all 90-degree angles, and this diagonal splits the 90-degree angles into two. So one way is to just see 90 degrees divided by 2 is 45 degrees. So part B, angle x, right? So angle x equals 45 degrees. All right. So part C, we're asked to look at the triangle to the right is equilateral, right? Every side is 2n. Okay, what is the length of the altitude? So the altitude is basically the perpendicular length from this vertex up here to the base. Okay, so what is the length of the altitude? Well, again, if we have an equilateral triangle and we have, these are all length 2n, to find the value, find the length of the altitude, k, which is the height of this triangle, we can look and split this triangle up into two right triangles. We have one on the left and one on the right here. So I just split it up down the middle. We know both of these are k. This is 2n here. This is 2n. This plus this is 2n. So we know this is, we split it in half, we get n and n. So now we have our right triangles. We can look at either one. So let's look at this one. We know from the Pythagorean theorem, c squared is a squared plus b squared. The hypotenuse is 2n, so it's 2n squared equals, and then k squared plus n squared. 2n squared, that squared goes and is distributed to both the two, so it's 4 and n squared equals to k squared plus n squared. We're trying to solve for k, right? So let's subtract n squared from both sides. We get 3n squared is equal to k squared. Okay, again, we square root both sides. We get k on the right, and we are looking at length, so it's positive only, is going to be the square root of 3 times square root of n squared, so that's the square root of 3 times n equals k. So our altitude, the height of this triangle right here, is square root of 3 times n. Okay? And what is the measure of angle y right here? Okay, so this, like we did in part B, we can, if we know this is an equilateral triangle, right? So these are all, the sides are all the same, right? We also know, and this is angle Y, we know that for an equilateral triangle, all three angles are the same as well, because this angle opens up to this side, and this angle opens up to this side, and this angle here opens up to this side, but an equilateral triangle is also equal angular triangle. So that means for our triangle, this angle is also y, and this angle is also y. And then remember that if we add up all three angles inside of a triangle, so if we have y plus y plus y, these three angles, we get 180 degrees. Okay, this is true for every triangle in the world. If you add up the three angles inside of it, no matter what kind of triangle it is, they add up to be 180 degrees. Okay, so y plus y plus y is 3y. Let's divide both sides by 3, and then we get y alone is equal to 60 degrees. Okay, and this is good because we know equal angular triangles and equilateral triangles, they always have all three angles being 60 degrees. Alright, so this ends CPM Precalculus Chapter 1, number 105.